this is Integrated 2914. I'm a little bit disappointed with myself. I was about 10 minutes into this video and then someone called and I didn't realize I could pause videos. Apparently I can pause and restart videos. I'm a dummy. So we're looking at absolute value functions, and before we do absolute value, I want to talk a little bit about exponents. Because when we have x squared and we ask what, let's say x squared equals 9, and we ask what x can equal, this implies there's two answers. X could equal 3 because 3 squared is 9, but x could also equal negative 3 because negative 3 squared is also 9. The same is true for absolute value. We still have two answers. Now, I hope that you guys know that absolute value essentially counts how far you are from 0. So if you're at negative 9, you're 9 steps away from 0. And if you're at 9, you're 9 steps away from 0. So absolute value is always going to be positive. So if I'm saying the absolute value of a number that equals 9, well, I could plug in 9 for this. The absolute value of 9 is 9. But I could also plug in negative 9. The absolute value of negative 9 is also 9. So I'm looking at two possible answers to plug in there. And I want you to keep that in mind as we go through this video. So the first thing it said is consider the function machines below f of x equals the absolute value of x. And if we know that if we plug in negative 9, the absolute value of negative 9 is 9. If we plug in 7, the absolute value of 7 is 7. If we plug in the square root of 2, the absolute value of the square root of 2 is the square root of 2. If we plug in negative square root of 2, the absolute value of negative square root of 2 is the square root of 2. So they ask us to move on to this one, to determine the missing inputs and outputs. And they want us to make sure we state all possibilities. So what can I plug in to the absolute value of x to get a 4? Well, of course we can plug a 4 in, but we can also plug in a negative 4. The absolute value of negative 4 is 4. What about a negative 16? If I plug in a negative 16, I'm going to get a 16. Again, I'm not going to get a negative 16. The absolute value is always positive. Negative 16 is 16 steps away. When we're saying, here we're saying, what numbers are 4 steps away from 0? Well, 4 and negative 4 are 4 steps away from 0. Here we're saying how many steps away from 0 is negative 16, and it's 16 steps. So again, what numbers are 9 steps away from 0? Well, 9 and negative 9 are. And here, what number is negative 3 steps away from 0? Well, there aren't any numbers. That's a trick question. There's no numbers that are negative 3 steps away from 0, so we'll have no solution to that one. It says if you're given an output for this machine, how can you figure out the input? Well, if you're given an output, you know that the input could be positive or negative. The only one that actually has one answer is the absolute value of 0. That has one answer. All right, so make a complete graph for f of x equals the square root of x, then fully describe the graph. So this is going to be kind of interesting, I think. I'm going to go ahead and give myself a little bit of white space to work on and make this table. And it says f of x, the absolute value of x. So what we're really saying is, and don't forget, f of x is like the y, right? So I'm going to plug in for the x and get the y. So what numbers can I plug in? Like what we said, if I plug in 0, I'm going to get 0. That's the only one that's like that. But if I plug in 1, the absolute value of 1 is 1. Well, how about if I go backwards and plug in negative 1? What's the absolute value of negative 1? It's also 1. And what about 2? If I plug in 2, the absolute value of 2 is 2. And the absolute value of negative 2 is also 2. I think you see where I'm going with this. If I plug in 3, I'll get 3, just like if I plug in negative 3. So let's go ahead and take a look at what if we graph this. I go negative 3, 3, that would be like this. Negative 2, 2 would be like this. Negative 1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. So I get this V shape. And obviously I could plug in like negative 2.5 and negative 2 1/4, so this is continuous. If you recall from integrated 1, there's discrete and continuous, so we're looking at continuous here. So we get this V shape. It's very similar to a parabola, but a parabola is like a U shape. An absolute value is like a V shape. Hopefully that makes sense to you. Go ahead and erase this, and we will continue along our journey of 914. Okay, so it says transformation team challenge. As you did with parabolas, list all of the possible all the possible types of transformations of the graph f of x equals absolute value of x. For each transformation you list, show how the graph and its equation. Then write the graphing form equation for the family of absolute value functions. So I don't know if I still have it in Desmos. I do. So what they're asking us to do is just like we did back when we did this problem. But instead of it being a parabola, they're asking us to change this to absolute value. So let's see if I can add in absolute values anywhere. You know, actually, I think I might know how to do this. If I hold... I thought I saw this. Shoot. I'm looking for the absolute value sign, and I'm not seeing it, so I'm hoping it'll show up under something else. I was looking for it on the keyboard, and I couldn't find it. You know, this might be a good time to pause the video. The absolute value is right there. I should have seen it a long time ago. So if I go here and put the absolute value in, you can see that what the book is wanting us to understand is we have the same A, H, and K that we did. This A is going to either make it go negative and steep, or it'll go positive, flat, steep, whatever. And it's the same rules. If it's between 0 and 1, it's going to be flat, right? Kind of like a bird flying right there, flapping its wings. If it's very negative, it's going to be steep and negative. If it's very positive, it's going to be up and steep. So same rules as the parabola. H is still going to move us left and right, just like the parabola. And K is still going to move us up and down, just like the parabola. So we end up with this exact same equation. It just looks, I mean, it's obviously a little bit different, but it's just still the same A, H, and K. And what you're going to learn in Integrated 3 is that there's actually a lot of shapes that subscribe to this A, H, and K rule, where you can make it steeper with an A, you can move it left and right with an H, and you can move it up and down with the K. But I will leave that for your Integrated 3 teacher to show you, but it's kind of cool stuff. So as you did with parabolas, list all the possible types of transformations. So again, we will say f of x equals a absolute value x minus h absolute value plus k. So instead of putting this parentheses with the square sign, we're going to put an absolute value, and then we'll know what's going on here. So use your knowledge of absolute value functions to write an equation for the graph at right. Well, I know the vertex is right here. It's at 1, 2. So I can go into this equation, and I'm going to go ahead and say x minus 1 plus 2. Now I need to get my a. Well, I know it's going to be negative. It surely opens down, and it looks like it goes down over 1, right? Down 1. So it looks like minus 1. So there's my equation for that graph. So pretty simple to do if we understand the graphing form of A, H, and K. Without graphing, determine the x and y intercepts of the graph g of x equals 4/5 minus 2 x minus 2 minus 2. So again, I know it sort of has a vertex at 2 and negative 2. So that's going to be my vertex. I'm going to have my x and my y. So it's going to be at 2, negative 2. So if I want to get my y-intercept, I'm going to plug in 0 for x. So if I plug in 0 for x, I get 0 minus 2. So I'll just sort of do this here. 0 minus 2 is negative 2. I know that the absolute value of negative 2 is 2, so that's going to be 4/5 times 2 minus 2. So that's going to be 8/5 minus 2. Well, I could also write that as 8/5 minus 10/5, right? I mean, isn't 2 10/5 just to make it easier for me? And it's negative 2/5. So I'm going to get negative 2/5 when I plug in 0 for x. That's what I'm going to get. And what about if I plug in 0 for y? If I plug in 0 for y, I'm going to get 4/5 absolute value of x minus 2 minus 2. I'll add 2 to both sides. It's kind of a weird question out of nowhere. I normally skip this question, but I was doing the video, so I figured I would do it, but I think I see why I normally skip it. We're trying to exploit the fact that we know that we have the x and the y intercepts, and they kind of go through when we have zeros, right, for the x or for the y. That's kind of the logic I'm using here. So I'll multiply by 5/4 to get rid of that. That'll cancel out. That'll give me the absolute value of x minus 2. This will cross out and give me 2, so I'm going to get 5/2. And then this could be positive or negative, right? The absolute value of x minus 2. So I get 5/2 is going to equal x minus 2, and I'm going to get negative 5/2 is going to equal x minus 2. I'll add 2 to each side. So I'm going to get 4 9/2. This is a weird problem. So I'm going to get 9/2, 0. And then if I add 2 over here, that's like adding 4/2. So I'll get negative 1/2. So I'll get negative 1/2 and 0. So my suspicion is that's what I get. I'm going to go ahead and jot this thing down and run over to Desmos to see if I actually got it right. So 4/5 x minus 2 minus 2. So let's jump over to Desmos and see how we did here. If we have negative 1/2, 9/2, etc. So we will say that the a was 4/5, right, which is the same as 0.8. So we'll move this to 0.8. We said x minus 2. So that's actually going to be like a plus 2. And then we're going to put this at minus 2. And we have it crossing at negative 1/2 and at 9/2, which is 4.5. And then we have it at 0 and negative 2/5, which I believe is what we had. So that was correct. It's kind of a tough problem. I'm not sure why they went after so ruthlessly on that one. Anyway, I wouldn't expect to see anything like 940 on the test. I'm just happy I didn't really look ahead. I didn't see that problem coming, and I'm glad I got it right. So I'm going to call it a night. I hope you're doing well. Reach out if you have any questions or problems. Talk to you later.